We are starting section 3 of Unit 4, and we are going to focus on, in our notes here, looking at how to divide monomials. And before we get too far into that, we're going to look at some interesting patterns and see what we can observe and why that might explain some weird things in math, such as exponents of 0 or negative exponents. And so I'm going to leave some space here, and I'm going to start writing a little bit off to the right, and I'm going to write 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4th power. And below that I'm going to write what they equal. Well, 2 to the 4th is 2 times 2, which is 4, times 2 again, which is which is 8, times 2 again, which is 16. So that's going to equal 16. 2 to the 3rd is 2 times 2, which is 4, times 2 again, which is 8. 2 squared is 2 times itself, so that would be 4. And 2 to the 1 means 2 times itself once, which means it's just going to be 2. Now you see here we're counting in an interesting pattern by doubling each time. We are multiplying by 2 since that is our base. We are multiplying by 2 each time. So 2, 4, 8, 16. Our next one, 2 to the 5th, would be 32, and so forth. Now I want you to add in some additional ones that we didn't write right away. And so over here we're going to write 2 to the 0, 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, and 2 to the negative 4th. Now, instead of trying to figure out what these are, we're just going to keep our pattern going as we go backwards this direction. So if we go backwards this way, we are dividing by 2. 16 goes down to 8 by dividing by 2, which is our base right there. So we're going to divide by 2 again to get to 4. Then we are going to divide by 2 again to get to 2. So we're going to continue our pattern. We're going to divide by 2 again, and 2 divided by 2 is 1. So 2 to the 0 is 1. That's interesting. We're going to continue our pattern dividing by 2 one more time, and we're going to get 1 divided by 2 is 1/2. 1/2. Well, let's do that again. Let's keep going. 1/2 cut in half. 1/2 divided by 2 is 1/4. And if you cut that in half divided by 2, you are going to have 1/8. And you continue that on, you're going to have 1/16. And so you end up with an interesting property. And what that is it says that 2 to the 4th, if that's 16, then 2 to the negative 4th is 1/16. You take whatever 2 to the 4th is, and instead of having it be on the top, you put it in the denominator of the fraction. You move it to another part of the fraction. Same thing with any of the other negative exponents. And when you have something to the 0 power, no matter what it is, the answer is going to be 1. So let's go ahead and try an example with x. Let's write out x to the negative 4th, x to the negative 3rd, x to the negative 2nd, and so forth. And we're going to go all the way up to x to the 4th, because we want to see how this pattern matches up. And when we do that, x to the 4th is just going to be plain old x to the 4th in its plainest form. X to the 3rd, x to the 2nd, x to the 1st. X to the 1st we could just write as x. That's probably the way you're most likely to see it. And what's happening in each of these cases here is you are dividing by x. You are dividing out an x. And when you take x cubed and divide it by x, you get x squared. And when you take x squared and divide it by an x, you get just plain old x. And when you take x divided by x, anything divided by itself, even variables, even letters, anything divided by itself is 1. So just like up here, 2 to the 0 is 1, x to the 0 is 1 as well. Doesn't matter that it's a letter. Anything to the 0 power, even if it's a group of things, to the 0 power is 1. and you continue that pattern of dividing by x. Well, 1 divided by x is going to be 1 over x. You can just write 1 divided by x as a fraction. And you can imagine what happens if you continue this pattern. You divide by x again, you end up with another x in the denominator being multiplied times that original x. So you get 1 over x squared, 1 over x cubed, 1 over x to the 4th. And what's happening down there is you're just taking whatever you had on top, writing it in the denominator, and the negative power becomes a positive power. So all of those hopefully are helping you to see an interesting pattern that we're going to be working with here. Another situation would be, what if you started with something like 1 over x to the negative 4th? The same property applies. You would move it to the other part of the fraction and write it as positive. So you would write it as x to the 4th on top. You could write that over 1. Now when a fraction is over 1, we don't really need to write that, so we could just write it as x to the 4th. So whenever an exponent is negative, it means you can move it to the other part of the fraction and make that exponent positive. So now we're going to move on to talk a little bit about what happens when you have exponents on top and bottom. How do you deal with that? How do you reduce systems or multiple exponents in the same fraction? So let's say you have something like x to the 3rd over x to the 4th. What does that equal? The way I like to look at problems like this, you always have to make sure that you have no plus or minus signs going on. Whenever you have addition or subtraction, things get a little bit different. We'll look at that in later sections, but for now, everything is either multiplication or division, so we don't have to worry about that. When I look at this, I have more x's being multiplied on the bottom than I do on the top. And I want to just kind of write this out to make it a little bit clearer. On top, I have x times x times x. On the bottom, I have x times x times x times x. So right here, I have x over x. And we know that anything divided by itself is 1. So those are going to actually reduce to 1. These are going to reduce to 1. These are going to reduce to 1, leaving us with just an extra x on the bottom. So that's going to be reduced to 1 over 1, to 1 over 1, to 1 over 1, and we just have that x. So when we multiply this out, I'm going to be left with a 1 on top. You can't just leave it empty. You have to leave that 1 there. Now on the bottom we have 1 times x, which is just x. So we're left with 1 over x. A shortcut to doing a problem like that would be to look at the original one and say, I have x being multiplied 3 times on top, 4 times on bottom. Which one has more, the top or bottom? The bottom has more. How many more? 1 more. So then I'm going to leave the x on the bottom and make it a power of 1. That's kind of the quick way to do something like that. We're going to do another example that has numbers also present and other letters. So let's say we have something like 2y to the 2nd, x to the negative 2nd, x to the 1, all over y times x to the 3rd. And let's make this a negative 2 just to make it interesting. When you have a problem like this, you need to make sure you're separating negative exponents and negative numbers as totally separate things. I'm going to highlight all the things with negative exponents here. Notice I didn't highlight the negative 2 out front because it is not an exponent. That negative 2, really, if I were to write that out, has an exponent of 1 because it is just being itself. It is not being multiplied multiple times over. So that negative 2 has an exponent of 1. It does not have a negative exponent. So what I am going to do, and I have the benefit of doing this with cut and paste, you might have to scribble this out on your paper. I'm going to take that and physically move it to the denominator. And when I do that, my negative exponent becomes positive. Now I have a positive x to the an x to the positive 2nd in the denominator of this fraction. I want to clean this up a little bit. So on top I still have that negative 2. I have a y to the 2nd power and an x to the 1st power. On the bottom, I have a y, and that's to the first power. It doesn't have it written, but I'm going to write that. And then x to the third, and then 2 more x's being multiplied. So I'd have a total of 5 x's being multiplied together, x to the fifth. Finally, I move into the phase where I figure out which one has more of each exponent. For the -2, it's the only number part in there. That's going to stay where it is. For the y's, I have y being multiplied twice on top. I have y being multiplied by only once on bottom. So that means that the top has more. Specifically, it has 1 more. So I'm going to put a y to the 1, or just y on top. For the x's, I have x to the fifth on bottom, x to the first on top. There are x's being multiplied 4 more times in the denominator, so I'm going to put x to the fourth on bottom. And that's going to be, right here, my final answer. So as you do these problems, make sure that you're careful to clean it up distribution-wise with your exponents when you have situations where that applies. Make sure that you look at which one has more top and bottom, and only do all of that after you've moved all of your negative exponents so that everything you're working with has a positive exponent.